Hello friends, welcome to my YouTube channel Dark Study. I have also created another channel activity series. In that channel, I have done all the activity practically which I have explained in this channel. Link is given in description, go and check it out. So our today topic is, can matter change its state? As you see around yourself, you observe the weather changes, sun rises, etc. Does these things make any change in the states of the matter? We will know about this later on. In this book, water's example is given as it can be easily found and exist in all three states. Water exists in solid state as ice, liquid as water, and in gaseous state as water vapor. How does the water particle can exist in all these states? How and when they changes its state? From where does they get energy to change this state? We can answer all these questions only when we will study our next topic. Our next topic is effect of change of temperature. Here another activity is given, activity 1.12. To do this activity we require thermometer, beaker, ice, burner, iron stand. First we will take some ice cube in the beaker. We will put thermometer in it and heat the beaker with burner. Now we will note the temperature of ice and when ice changes into water and when water changes into water vapor. From above observation, we can conclude that temperature does not change when ice changes into water and water changes into water vapor. As on your screen, you can see that this graph shows the effect of temperature on physical state of water. As you can see, friends, we know that when temperature increases, kinetic energy of the particles also increases. Due to this, the particles of matter starts moving away from each other, and a stage is reached when matter changes its states. As you have seen in the activity, ice changes into water when heat is supplied. So the temperature at which a solid melts to become a liquid at the atmospheric pressure is called the melting point. The melting point of ice is 273.16 K, means 0 degree. The process of melting is also known as fusion. We have observed that the temperature of the system does not changes after the melting point is reached till all the ice melts. Friends, why does this happen? As the heat energy absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the content of the beaker and is known as latent heat. The word latent means hidden, as the amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure and its melting point is known as latent heat of fusion. This is the definition of latent heat of fusion. As we are supplying heat energy to water, the particles are still moving and even more faster, and a certain temperature is reached at which the particles have highest kinetic energy, which leads to move the particles away from each other. At this point, the water in liquid states starts changing into gaseous state. The temperature at which the liquid starts boiling at the 1 atm means atmospheric pressure is known as its boiling point. For water, this temperature is 373 K, which means 100 degrees centigrade. Friends, as I have told you the definition of latent heat of fusion, like that way we will define the latent heat of vaporization. So friends, say with me, the amount of heat energy that is required to change 1 kg of liquid into gas at atmospheric pressure at its boiling point is known as the latent heat of vaporization. So friends, as you see this figure tells us that the matter changes its states when change of temperature takes place. As we have learned that substance can change states from solid to liquid and from liquid to gas. But can you imagine that a substance can even change from solid to directly gaseous state without passing through the liquid states? Friend, as you can see in this activity, ammonium chloride, which is in solid form, directly changes into gaseous state. This type of changes are called sublimation. Now, our next topic is effect of change of pressure. Friends, you have seen that we change solid into liquid and liquid into gas, and also solid directly into gas. These types of changes are called physical changes. So these changes can be reversed as gas changes into liquid and liquid into solid. Also, gas can directly change into a solid state. We call these changes as a reverse change. When gas changes into liquid is called condensation. When liquid changes into solid is called solidification. And gas directly into solid is called sublimation. So, how can we do these changes? This can be done by applying pressure and changing temperature. As in the figure, you can see that in a cylinder with the help of a piston, force is applied and the particles which are away from each other comes together and changes their state. As in first cylinder, gas is there which changes into liquid state and liquid state changes into solid state. These things are done by applying pressure and reducing the temperature. As you have heard about solid carbon dioxide or dry gas, what are these? These were the gases which is compressed into solid state by decreasing pressure to 1 atm. This leads to change gas directly into solid state without passing through the liquid state. Thus, we can say that pressure and temperature determines the states of a substance. Here, one figure is given. Try to remember this figure and keep in mind while giving exam. Friends, our next topic is evaporation. What do you mean by evaporation? These questions frequently come in exams. We can define evaporation as the phenomena of change of liquid into vapor at any temperature below the boiling point of liquid. It's called evaporation. As we analyze this thing that the evaporation takes place in our daily life, as you keep your wet clothes to dry, the water particles present in that goes away when you keep it under the sun for the long time. As you can see, these things takes place below the boiling point. So these are called evaporation. Friends, our next topic is factors affecting evaporation. To understand this, we will do the activity 1.14. To do this, we will take 5 ml of water in a test tube and keep it near a window. Taking another 5 ml of water in an open china dish and also keeping it near the window. Again, we will take 5 ml of water in an open china dish and we will keep it inside a cupboard. Now we will record the temperature and the time and days taken for the evaporation to take place. From the above observation, we can conclude that when surface area increases, the evaporation process also increases. As in above activity, 5 ml of water which is kept in china dish near window will evaporate faster than in test tube. Second thing that we noticed that when temperature increases, the evaporation also increases. As in sunny day, you see that your wet clothes dry faster than other days. The third thing we notice that when humidity decreases, evaporation increases. As in rainy day, the evaporation rate is very low, as you can see your clothes dry slower in these days. The fourth thing we noticed is increase in wind speed increases the evaporation. As you can see friends, in windy day your clothes dry faster. Friends, we will now recap the factors that affect evaporation. First point, when surface area increases, the evaporation increases. Second point, when temperature increases, the evaporation increases. Third point, when humidity decreases, the evaporation increases. And fourth, the last, when wind speed increases, the evaporation increases. Friends, try to remember these factors. Our next topic is how does evaporation cause cooling? As we know, liquids evaporate, but these particles of liquid absorb energy from the surrounding to regain the lost energy in evaporation. They mainly absorb surroundings cools. That's why they cause cool. After a sunny day, many people sprinkle water on the roof. Why? Because the water is sprinkled in the roof absorbs the heat from the roof and evaporate, which leads to cool the hot surface of the roof. Also, during summer day, we wear cotton clothes. Why? Because cotton is a good absorber of water, which helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation, and this makes our body feel cool. Friends, we also see some water droplets on the outer surface of glass containing ice cold water. Why does this happen? As water vapor present in air comes in contact with the cold glass of water, they transfer their heat energy to glass and becomes cool. As they become cool, they changes their state into liquid, which are seen at the surface of glass. With this, our chapter ends, and this video also. If you have understand then like my channel and support me so that I can make more videos of study. If you will support me more, then I can make animated video for the science teaching and share this video to your friends so they also get a proper knowledge. Thank you.